Consider the following quadratic function. Y equals negative x squared plus 2x minus 1. Step 1 of 6, find the vertex of this function. This equation is in standard form, so we will use the fact that h equals opposite of b over 2a to find our vertex. In this problem, a is negative 1, b is 2, c is negative 1. H equals opposite of 2 over 2 times negative 1, which is negative 2 over negative 2, which is 1. And to find my k value, I'm going to plug in 1 to the original function. The opposite of 1 squared plus 2 times 1 minus 1. 1 squared is 1, so we have negative 1. 2 times 1 is 1, so plus 2 minus 1. Negative 1 plus 2 minus 1 is 0, so my vertex is 1, 0. My vertex was 1, 0, and we know that for step 2 of 6, we're supposed to find the line of symmetry of this function. The line of symmetry is x equals h, which in this case is x equals 1. Step 3 of 6, find the x-intercepts, if any. Express your answer as ordered pairs. When we have our x-intercepts, we know y is equal to 0. So I'm going to set this equation equal to 0. 0 equals negative x squared plus 2x minus 1. And I'm going to see if I can factor this first. I don't like a leading coefficient that's negative, so I will divide everything by negative 1. 0 equals x squared minus 2x plus 1. And that factors into x minus 1 times x minus 1, which means x is 1. We actually end up with 1 x-intercept, and that x-intercept is 1, 0. Step 4 of 6, find the y-intercept. Express your answer as an ordered pair. With our y-intercept, our x value is equal to 0. And when we have an equation that is in standard form for a quadratic, the y-intercept is the same thing as your c value. So in this case, that is negative 1. As an ordered pair, that looks like 0, negative 1. Step 5 of 6, determine 2 points on the graph of the parabola other than the vertex and the x and y intercepts. So those are the values I cannot use. I'm just going to create a table of values with x and y. I do like to use my vertex as that point in the center, so I'm going to use 1, 0 there. And I'm going to choose a value on each side. Typically, I would go with 0 and 2, but in this case, 0 is one of my values, so I can't use 0. So we're going to go with negative 1 and 3. When I plug in negative 1, I have negative 1 squared plus 2 times negative 1 minus 1. Negative 1 squared is 1, making that negative. It's negative 1 plus 2 times negative 1 is negative 2. So we have negative 1 minus 2 minus 1, which is negative 4. When I plug in 3, I have negative 3 squared plus 2 times 3 minus 1. 3 squared is 9, which making that negative is negative 9. 2 times 3 is 6, so that's plus 6 minus 1. Negative 9 plus 6 is negative 3 minus 1 is negative 4. So my two ordered pairs are negative 1, negative 4, and 3, negative 4. Step 6 of 6 is to graph the quadratic function. So I have 1, 0, which is my vertex and my x-intercept. 0, 1 is my y-intercept. And this is one point, and this is the other point. So I'll start with my vertex. 1, 0 is here. My y-intercept is 0, negative 1, which is here. I have the point negative 1, negative 4. And the point 3, 4. So my parabola looks like this.